Hello again, everybody, and today we'll be doing the geometry of circles. So we'll be going over some terms that are associated with circles, such as diameter, radius, chord, segment, sector, area, circumference, and arc. So let's first look at circle number one. Circle number one has a straight line drawn from one end to another end, passing directly through the center. This line is known as a diameter and it cuts a circle fully in half. The space between the outer part of the circle as well as the diameter is known as a semicircle, and it's a perfect 180 degrees. 180 degrees. Because as you know, the full circle is always 360. Now let's look at circle number two. And circle number two, we have a line drawn from the center to a point on the circle. This line is known as the radius, and it is always equal to half of the diameter. As you see, if we were to extend this line, we would end up with another diameter as we had in the first circle. And so we can conclude that the radius is always half the diameter and joins the center to any point on the circle. Now we have what is known as a chord. A chord just joins any 2 points on the circle by a line. It doesn't have to be through the center. So a diameter is a chord, but a chord isn't necessarily a diameter. And the area between a chord and the end of the edge of the circle is called a segment. Now let's look at 4. At 4, we have what is known as a sector. A sector is formed in the space between two radii and the end of the circle. And then this small end part of the circle here, outer part that encloses the sector, is known as an arc. So as a sector is formed in the space between two radii and an arc. Now let's move on to the equations of a circle. Now there is one important constant that you must know, and it is known as pi. This constant was developed many thousand years ago by Greek mathematicians. Well, let me draw it a bit better than that. Pi, and it is valued at 22/7, sometimes written as 3.14. However, the 3.14 isn't an exact value. Pi cannot have an exact decimal value as it goes on for quadrillions of digits. So in my opinion, it's usually best to use pi as 22/7 and then convert your final answer to 2 decimal places when working. So let's go with the first equation. Now the outer part of the circle here, which would normally be called the perimeter in other shapes, is called the circumference. So the entire distance around the circle is called a circumference. And the equation for this is circumference is equal to pi times the diameter. And since the diameter is 2 times the radius, we can say that the circumference is also equal to 2 pi r. These are two very important equations that you must know. Now, the other very important equation would be the area of a circle. And for that equation, it goes area is equal to pi times the radius squared. Pi r squared, that's the equation for area. Now this equation is gonna come in handy with finding the area of the sector. The area of a sector, let's say the angle in this sector here is theta. So the angle in that sector there is theta. The portion of the area taken up by this angle would be equal to the angle which is theta all over 360. So that's the portion of angle taken up by this part here. And then to find the area of the sector, we would go ahead and multiply that times the area of the whole circle, which is pi r squared. Therefore, we can say that the area of a sector is equal to theta over 360 times pi r squared. Now let's look at the length of an arc. The arc is this small part on the circumference here, and we can represent it by saying its length over the entire circumference, which is c. But we don't know this length. So to calculate it, you can say that length of an arc, let's write this as length a down there for arc, is equal to the same angle theta over 360, but this time multiplied by 2 pi r. And that's about it for the geometry of a circle. See you next time.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.